Hi there, my name is Benjamin Weimer, and I am a student studying mechanical engineering at the university, at Embry-Riddle Aeronautical University in Prescott, Arizona. I'm studying propulsion systems. There is a specific track at our school for what you want to focus on, so I'm studying propulsion systems. I'm very interested in gas turbines and jet engines, so I get to work with those a lot in a lab on campus called the Propulsion Lab. But I'm making this video today to serve as a virtual resume portfolio and really to tell you about this project that I've been working on for quite some time. It all started basically back in December of 2023, but I guess it traces its roots back even a year before that, all the way back to 2022. I had the desire to build this. So when I was, I think it was 2022, after graduating high school, I was not really sure what I wanted to do in engineering, but I always had this interest with combustion and flames. So I built this little combustor, and it was just a simple tin can thing. I had found a YouTuber who had made a demo on how to do it, and I followed that, and I was able to make a functional butane gas combustor. Very simple, but it actually did sustain a flame, and that sparked a flame within me, no pun intended, to pursuing jet engines. So after a year of research at the University of the District of Columbia in Washington, D.C., I transferred out to Embry-Riddle in Prescott to study propulsion systems here. They have a great program for it, and I get to do a lot of hands-on research there. Last summer, I guess this started in December of 2023. So this was the winter that I was coming into Embry-Riddle. I had the ideas of building some sort of turbojet engine from scratch. It all starts with the combustor. So I had been doing some math there, some preliminary scratch notes and drawings. I did some basic math using math from people on a different website that I had found online. And so at that point, I had not taken any thermodynamics. I didn't really know anything, so all those calculations were really rough. But in that winter, on a winter break, I think I had 3 weeks in December 2023, so that was about 9 months ago now. I did a bunch of math on my engineering notebook. So I found a website that gave some basic formulas based on the inducer size of a turbocharger that you wanted to base a small gas turbine off of. And so I bought this thing in Facebook Marketplace for $50. The compressor's actually cracked. I will have to rebuild it before I eventually test it. But this and these dimensions and these calculations that I did were based off the inducer size, which makes some assumptions about the airflow going into the proposed engine. So I kind of took that and ran with it. I had a very productive December. I did a lot of work. I 3D printed and prototyped this combustor that you'll see behind me, this blue one here, that bolts up to the turbine that I have here. So I'll show you a little bit of what it looks like. So these are kind of what the formula spat out. The flame tube goes on the inside, and you're injecting your fuel and your ignition here. And then it bolts up to the turbine flange on the turbocharger. So that is eventually the goal of what I would like to do with this project. But it all started with the combustor, and that's something that's a lot more important that the director of my lab had informed me of. He said you really want to focus on getting a good combustor and being able to properly combust whatever fuel you're using. In this case, I'm going to use propane. So here is actually, many months later, the fabricated version. This will be the propane combustor. I machined it myself. The welds maybe aren't great. I have some good ones, some bad ones. Welding sheet metal was a little bit of a challenge for me to learn. So, still have to maybe do a little bit of fixing before testing, we'll see. But the basic components of these, and I'm gonna show an exploded diagram a little bit later so you can see how I went about it. But it has lots of components. The main ones are there's the flame tube, flame liner on the inside where the combustion takes place. You have the outer liner here. This is where compressed air is delivered hypothetically from the turbocharger into there. Right now I'm going to be simulating that with the leaf blower, over which I have control on the motor speed. So I can do a variable control on the air coming in, and therefore the pressure also. And then so we have the fuel coming in here. This is propane, and then I have ignition right here. I will show that in later videos on the test stand, but there's electronic ignition that's all run from a control board that I designed. It's going to stand on these 80/20 rods. I actually have to cut these down a little bit more nicely, but they are about 3 inches long. And then you have the main flange here, and you have a reduction from circular to rectangular cross-section. That was quite hard to do. Perhaps in the future I will not do that, but it was my first time doing it, so I figured it was all right if it didn't look perfect. But you have a similar kind of reduction of cross-section in the inner flame tube as well, and you have a dilution air sleeve basically that comes around the outside here, and we just have primary zone holes on the flame tube. The idea there is that it simplifies things a little bit, and no matter what, I'm going to be getting the cooling air, and that will cool down the air before it hits the turbine, hypothetically, if I can get to that point. But that's not what I'm here to talk about today. So the combustor is done, and hopefully I'll be testing within a week or two. I just purchased some a pressure regulator, 60 psi I'll regulate it down to, and then I have a valve that I'll manually be able to crack open for fuel flow regulation into the engine. That's all on the test end, and I will be able to show you that. But just want to do this little intro video. I have a cool video in the machine shop of this combustor that I'm going to play after this, and then I have the exploded diagram I'm going to show of the combustor, exactly how I manufactured it. It was made the exact same way, and that's what the exploded diagram is going to show. So just wanted to make this video to explain what my project is about. I hadn't made anything long format before this, so here we go. And hopefully I'm going to be able to edit together some nice, interesting clips in a perhaps more theatrical way of the testing, and get some more up-close shots of the rig itself with the power source and the fuel flow control and electronic ignition and the air input, all that. Eventually, the test rig that is just testing the combustor will evolve into a full-on turbojet engine, and who knows how much thrust I could produce with that, but the first step is really to produce a quality gas generator, and the key component of that is the combustor. So I'm going to perfect combusting propane at this point. Thanks. All right, so here you go. You can see I'm going to take off the upper cap here. That's the flame tube on the inside. You can see the fuel injector and the spark plug. And so as referenced before, here's the exploded diagram view of the CAD model. This was made in SolidWorks. But yeah, thanks for watching, and I can't wait to post more about the testing.